Okay, welcome to a presentation on a technique of integration, and this technique is called the integration by parts. My name is Charles Wasfani Msipa. Okay, let's start this way. I think what you see on this first slide here is something which is familiar. First of all, we've got a derivative there of a function of a product of two functions. Remember, we agreed that when we read du, let's read that as derivative of u. So if a derivative of uv is derivative of u multiplied by v plus u multiplied by derivative of u. That's kind of a shorthand writing of that kind of. Then I think you're understanding that the integral is kind of an inverse to differentiation. If I introduce integral here, it's like I'm introducing ln on e. Then I must get back the argument. That's what I'm doing there. Then this will be the integral of that product, and that will be the integral of that sum. That will be the integral of that. So then let's unpack that further. Here what we're dealing with, let's remember, this is the product rule for differentiation. So that it is. So what we've just reflected on is that if we've got f inverse composed with f is the same as composing f with f inverse, we'll always get what? The argument. Agreed? I suppose we agree on that. Otherwise, if we don't agree on that one, then we've got serious problems. We must agree on it. So then, that motivates that if I introduce an integral on this one, uv, and then I'll be introducing integral on the sum, in this case, du v plus u dv. At this moment, I'm not worried whether u and v are functions of x or functions of t. I'm just talking about the simple derivative. So, removing the brackets there, we know that this is going to give us the v du plus integral u dv. I just commuted the two things, not a problem. That's a product. But we said here, this will give us what? U times v equals to v du plus u dv. That's what it's going to give us. Then I think you can see here that I can get two expressions out of this one. What is one expression? One, if I subtract on both sides, this expression, if I subtract it on both sides, I'll get a 0 here. If I subtract here, I'll get a 0 here. Then I'll have the integral, this one, u dv equals to uv minus the integral of v du. I could have decided to subtract this on both sides. I could get something else, which is in this case, if I get that, I would say integral of v du is equal to u times v minus what? Minus u dv. These two are saying exactly the same thing. They're simply saying, if I see, for example here, if I see a product under the integral sign, I must look at the product as one function which is not differentiated like u, and another function, a derivative of some function. But once I've got a derivative of a function, I know I can raise that function somehow. How can I raise the function? I've got a derivative in my hand. I want to raise the function. What do I do?
If I need the presence of a derivative, I can recover the function by the process of integration.
Is that clear, guys? Okay, now let's do this. Check this. Check this. Don't write infinitely. That's not a long note to write infinitely. Check this. What is said here? It said to integrate this, I will need v. But you don't have v. You've got a derivative of v. Which means from the v, you will have to raise v. All together. It said to integrate this, it's a u multiplied by derivative of v. I will need v twice, here and there. So you will have from the derivative raise v. But what else will I need? I will need u. U is given. But also I will need du, which means from u I will need to go down to du. Then make this up and call that the integral of that. That's simply what that thing is saying. One function is a derivative, and the other function is just a simple function without differentiating. So the one which is just a simple function without being a derivative is going to be differentiated. The one which is a derivative is going to be integrated. Then using those two, you are going to make up the integral of that. That's what that thing is saying. Do you understand what I'm saying? Do you see what is happening there? You are not going to proceed from here without having v, without having du. But v, you've got dv. You must know for a fact that if I've got a derivative, I must recover the function by integration. Are we there? Okay, then if you understand that, then we proceed this way. There is an example. Then I've got here x cosine x dx. Then I can say there I've got a u and what? V prime. That's what we saw there. That's what we saw in the formula. If you don't agree with me, say no. That's what we saw in formula. It's a u and a v prime. Is it? Yes or no? Then I've got to choose. I've got a choice to choose that I want to. I think cosine is a derivative of some function. X is a derivative of some function. But themselves sitting together like that, I must choose carefully. Who do I make u? Who do I make dv? Together. First of all, let's make an observation. Very positive observation. Powers of x can be differentiated with only a finite number of times. Right? That's not. Powers of x can be differentiated with only a finite number of times. Like for example, 4. X power 4 can only be differentiated 4 times. The 50 times is 0. Did you hear that? If you take x power 4, you can differentiate it only 4 times. By the 4th time, you differentiate the body constant. By the 50 times, you got 0. 60 times, 0. Now, they just vanish. A power of x, when differentiated successively, they just vanish and go to nothing. What about cosine? E. Sine of the body. Tan. Can they go to 0? No. Okay. Now, this is how I'm going to choose my u. Check. This is how I'm going to choose my u. I'm going to choose my u to be that function which is got a possibility of being differentiated to a constant substate. After that many times, you get 0. Now they vanish. If I now differentiate here and say du, I'm going to get what? 1. If there I've got cosine, it's a derivative. If I now ask for v here, what am I going to get? Sine x. Then I'm going to have sine x. Minus, I think it's sine x. So then if you look at what the formula said there, the formula said multiply u and the v. Then you write here x sine x. And they said subtract the integral of the two. I'm writing my sign there intentionally to show people what goes under integral sign. Subtract the integral of 2. So I subtract the integral of 2, of those two. Then in an integral sign, I'm going to have minus integral 1 sine x dx. Then what do? 1 sine x dx is just sine x. So what I have here is x sine x minus sine x dx. Do you see that now? I'm just integrating one equation. Now I'm here saying this thing. Here is a derivative. This derivative is sine. But sine is never a derivative of any immediate derivative of any function. It's minus sine, is it? Then I'm worried about where am I going to get minus sine? I can just play around with this minus sine. What do I do now? Come in the next place and say x sine x plus minus sine x dx. I just incorporated that minus sign inside the integral. Then what happens now? Is x sine x plus, this is the derivative of cos. The integral says here is the derivative. How do I get the function? By integrating. So it's just cancel cos x plus c. Let's get the next example. There are the examples, many of them. I'll do one. Let me choose this one. If you see that there are powers of x and there's something which never differentiates to 0 altogether. So when I'm taking this one, I'm going to write integral x squared e to the power 2x dx equals to, then I decide my u, my v prime. Okay, maybe let me say my u, my dv. Let's start on a u. Let's decide on a dv. Can I have one person who says, say, I understood what you said before. Can I choose for you my u and my v? Okay. X squared and what? E to the power 2x. That's good. Yes, my brother. Right? Then du will be equals to 2x. Then v will be equals to exponential function itself divided by the derivative of the argument. We agreed on that one yesterday. We said we can quickly call upon the immediate integral and divide by
the derivative argument. Remember that? At that point there, we don't add C. Like before in the previous example. At that point, we are doing those parts, looking at those parts. We don't add a C there. There's no C plus A. Okay? So then, what we do now? I call this a mantra. I call this a mantra. This thing which I'm writing now. Check what it's doing. That's the mantra. What's the mantra saying? It says multiply these two, subtract the integral of these two. It's my own word, it's my own character, it's my own symbol with which I pass a message to my students. Multiply these two, subtract the integral of these two. If you ask me where did I get that from, I just got that from my tricks of teaching. I must make my students remember these things very, very easily. This is how I do it. If you do it, if you lay out this thing differently, in your own way, which is not this one, you have to sort out yourself how do you organize it back to the formula. As I've done it here, I've organized it back to the formula. So how do I organize it back to the formula? I'll multiply u and v, which I'm going to get x squared e 2x over 2 minus, you can see the minus sign there, and then the integral of all what is on the left hand side of the integral, on the right hand side of the integral. What is there? It's a 2x, it's a what? It's an e 2x divided by 2, and then respect to x. Organizing that, I get x squared e 2x over 2 minus this 2 and that 2 that simplify to a 1. Then I've got integral x e 2x dx. Where are we? We're back to a product, another product which is not the one we started with, but less complicated than the one we started with. The one we started with was an x squared, and this one is an x power 1. Now together, you understand what I'm saying? So what I'm going to do, we're going to recycle this process. We're going to recycle this process. So now we can say this is the initial part which we did. Now we'll come to number 1. We have to declare our u. We have to declare our dv. I want the next person now to tell you what is going to be my d, what's going to be my dv. X, our dv, exponent of 12. There's no other choice. You've got two things. You make one thing, this, the other one is just an obvious choice. Is it? E to the power of 2x. Now du, I'm just writing it like that because we saw this before, isn't it? And then v, we saw this before. All together. Mantra. And then equals x squared e 2x derivative minus. Check what I'm doing here. This minus, I'm keeping it here. Check, please, before you write, check. I'm leaving this minus here. I'm putting a new bracket here to house this part of the integral. So then I'm housing that, as the mantra says x e 2x all over 2. Minus, now the minus of the formula from the beginning, according to this integral. So we minus the integral of what the integral sign. But I'm multiplying 1 by that. So when I'm multiplying by 1, a times 1 is just a, isn't it? So it's just a question of picking this and putting an integral sign. E 2x over 2 dx. All together. Next step, copy this, remove the brackets, then plus the integral half e 2x dx. But what we are doing here is exactly what we did there. Yes or no? There's no calculation we're doing here. It's exactly the calculation we did there. It's exactly the calculation we did before. Isn't it? So we just copy this. Then, if you make yourself too much work and struggle there and there, because you like the struggle, it's your problem. Questions? Now, notice something here. Observe something. Can you listen, please? Listen. I started with power 1. We did only one step, one choice of u and v. Now at power 2, I have to do 2 choices of u and v. But keeping the same principles, what do I choose to be? What? Okay. Then someone must guess, if I have power 4, if I have power 5, if I have power 6, what's the problem? There are the examples which you can do at home in the comfort of your home. Next thing, what do we have there? We've got 2 animals which have a dimension to 0. Then what do you do? That's the question. If you don't see what you're supposed to learn now, I would say in which you're here, not ready in this class. You see that we've got 2 things now, none of them go to 0. If we speculate very wrongly, we might think that will never stop. But if you think that is never stop, then I'll make you experience that it will stop. Check. This is what we're going to do. Let your I, your integral, be equals to e to the power 2x sine x dx. Do you agree? I don't mind. This group
this side, can choose U to be anything of their choice. This group can choose dV to be anything to be their choice. It's up to you. Are you together? So, but what I'm going to do here, I'm going to say e to the power 2x is that. And this says sine is that. Then my dV is going to be equals to 2e to the power 2x. And my v is going to be equals to minus cos x. My mantra, then I say, come and say here, equals e 2x with a minus multiplied by cosine x minus, look, it will be minus this minus and that minus, that will be plus. Do you agree? Yes or no? Then I've got integral 2e 2x cosine x dx. Got back almost to the same spot. What do I do now? Check. I continue with this thing same way. I will still choose my u to be exponential. In other words, I'm saying be consistent. Once in the first step you choose u to be one function, in the next step keep the same function to be u. In the next step change the same type of function to be u. So here I'm going to have du. You let me write dv instead of du. This is du. This is du. Du 2e 2x. dv in this case is cosine. But cosine is a derivative of sine. In the next case here, I keep this minus e 2x cosine x plus 2, open the brackets, mantra, that and that, e 2x sine x minus 2 e 2x sine x dx. Remove the brackets, minus e 2x cosine x plus 2e 2x sine x minus 4 integral e 2x sine x. And then I say, open your eyes. If you don't open your eyes, that integration will go on for life. Are you opening your eyes? Can you see? What did you see? The first integral I'm seeing a multiple of it. I'm seeing a minus 4 times I. I'm seeing a minus 4 times I. I'll do it. This is a minus 4, but this is I. Do you see that? So if you can see a minus 4 in I, I'm seeing a minus 4 times I, and this is I. So what it's saying here is saying I is equals to e minus e 2x cosine x plus 2 e 2x sine x minus 4i. Then I have an equation and the I unknown. Then solve for I. But to solve for I must group the like terms I together. So what I'm going to do, I'm going to add on both sides for I. I'm going to add on both sides for I so that I can have a 0 here. Then that side I'm going to have 5i equals to minus e 2x cosine x plus 2e 2x sine x. That is what we must get, guys. Are we together? That is exactly what we must get. I'm not claiming that I'm a wonderful magic teacher who can teach people to understand this thing once and for all. This needs revisiting. This needs thinking through the process, following the exercises, following the examples, and trying your own examples. That is the process of learning. Are we together? Okay. So I think at that point, at least you appreciate now that there's a method which can make you handle products. If I was to parallel this thing with differentiation, I would say the method I'm using now here is product rule for integration. But it's actually called, in literature, is described as integration by parts. Integration by parts. I don't know where are the parts, but I think you can identify the parts yourself. All together. Okay, that is integration by parts. But to master it, you must practice. Otherwise, at this point, guys, I would like to say thank you for listening. My name is Charles Wasfani Msipa.